Hello, ladies and gentlemen. We're going to do 9.5b today. We're going to be talking about absolute and conditional convergence. Our objectives are that we are going to classify a convergent series as either absolutely or conditionally convergent. Alrighty, so as we've been working with series, it is possible to have a series that has positive and negative terms, like we did in our last video, but it's possible that this could be not an alternating series. So for example, let's say I had the sum from n equals 1 to infinity of the sine of n over n squared. And if I wrote my series out, this would be the sine of 1 over 1 plus the sine of 2 over 2. Oops, I lied, over 4 plus the sine of 3 over 9 plus etc., etc. Okay, so on this particular situation, I'm going to have some negatives, but it's not necessarily an alternating sequence. So let's try to do what we did in our last video. So let's try to do the sum from n equals 1 to infinity of the absolute value of the sine of n over n squared. And if we did a direct comparison, and I'm not actually going to do the comparison, but we would get that the sine of n, absolute value, would be less than 1 for all n. So then that would mean that the sine of n over n squared is going to be less than or equal to 1 over n squared. So I kind of did do the comparison, so I lied just a little bit. And then n is going to be greater than or equal to 1. So then we would say, there's my lovely therefore dots, that the series would converge by the direct comparison test. So we have to be careful when we have sequences and series that have positive and negative numbers to distinguish between an alternating sign series or between a series that just has some positive and negatives, okay? And then I'm going to add that guy in there. All right, so now let's talk about absolute convergence. All right, and again, we don't have a really long video today. Is that a true statement? Oh, yeah, baby. This one's only 2 pages. Woohoo! So absolute convergence says if the series and the sum of the absolute value at a sub n converges, then we know that the series is also going to converge. All right, so let me scoop my paper up. So let's get some definitions of the absolute and conditional convergence. Whew, that's a lot of words. All right, so here are my conditions of absolute and conditional convergence. The first one is going to be that the sum of a sub n is absolutely convergent if the sum of the absolute value of a sub n converges. And then the second statement is going to be the sum of a sub n is conditionally, and I think it will make more sense after we do a couple of examples, convergent, if the sum of a sub n converges, but, and this would be why we have conditionally, the sum of the absolute value of a sub n diverges. Okay, so those would be our rules. So let's do a couple of examples. Okay, so the example says, same thing that they have said all the way throughout the chapter, determine whether or not the series is convergent or divergent. So we're going to have those guys. And then we're going to add an additional caveat that says classify any convergent series as absolutely or conditionally convergent. Whew, that's a lot of words. Alrighty. So let's say, and I'm going to do a couple of examples with the same directions. Remember, this blank slide means determine whether or not the series converges or diverges. So let's say in my first one I have the sum from n equals 0 to infinity of a negative 1 to the n, there's our alternating sign, times n factorial over 2 raised to the n. Well, if I look at those terms, this is going to be 0 factorial over 2 to the 0 minus 1 factorial over 2 to the 1 plus 2 factorial over 2 squared minus 3 factorial over 3 squared, etc., etc. And then we could say that by the nth term test, and I'm not going to go back and remind you of that now, but by the nth term test, then we would say the series is going to diverge. Okay? Alrighty, so then we're going to have the same directions for B, and this one's going to be the sum from n equals 1 to infinity, negative 1 to the n, there's our alternating sign, over the square root of n. Well, this is the same thing as a negative 1 over the square root of 1 plus 1 over the square root of 2 minus 1 over the square root of 3 plus 1 over the square root of 4, etc., etc. Okay, so we could use our alternating series test, which is what we've been doing for the last couple of days, and we could show that this particular series converges. But if we used a p-series, we would get n to the 1/2, then we would know that this diverges because p is equal to 1/2, which is less than 1. And so since it works for some and doesn't work for others, then we would say, therefore, the series is conditionally convergent, meaning depending on what type of test you use, you would get different results. All right, so I have one more set of problems, same thing. So we are going to determine whether it's convergent or divergent, and then we're going to have the same directions that you can't see. Here, I'll scoot it back down, and then classify any convergent series as absolutely or conditionally convergent. All right, so if we move back into the red zone, our first example is going to be the sum from n equals 1 to infinity of a negative 1 times n plus 1 divided by 2. Well, that's a hairy looking beast, over 3 to the n. But if you'll notice, on this one, I'm going to have n squared, which means that I'm probably going to always have the n squared means that it's going to make it positive, which is kind of cool. So this is not an alternating series because the signs aren't going to change. So since it's not an alternating series, that means that it's going to grossly resemble n equals 1 to infinity of 1 over 3 to the n, okay? And then this is just a cute little geometric series. Remember, I could write this 1 over 3 to the n, so my r is a third, which is less than 1, okay? So that means that this is a convergent geometric series. Well, that was very polite. All right, and then my last example, yeehaw, I told you today's video was a short video. We'll call this guy B. We'll go back and put an A up there. In this one, I'm going to have the sum from n equals 1 to infinity, absolute value, negative 1 raised to the n, there's my alternating signs, over the natural log of n plus 1, okay? math and I write out my sequence or my series, I'm going to get 1 over the natural log of 2, 1 over the natural log of 3, 1 over the natural log of 4. Okay, and if I did my alternating series test, and I would leave that to you to show that that is actually true, it would show that this particular sequence is going to, oops, I spelled it wrong, converge. Okay, but if I were to do a direct comparison test, this would be part of a harmonic series. Then this one is going to diverge. Well, that's a bummer. Since one converged and one diverged, then we would say, therefore, this particular series is conditionally convergent. Ta-da! That is it for today. Alrighty, I will see you soon.